Imagine waking up tomorrow morning, looking down at your body, and realizing evolution just repossessed your legs. No warning, no refund, just a cosmic memo saying, sorry, you're a noodle now, figure it out. Around 100 million years ago, that exact eviction notice was handed to the ancestors of snakes. Nature looked at lizards running around the Cretaceous dirt and decided that limbs were officially a waste of overhead. So over millions of years, the legs were canceled, the body got stretched out like warm mozzarella, and snakes became the ultimate tubes of pure muscle. Except for one massive detail. If you pick up a 20-foot python right now, flip it over, and look closely at its lower belly near the tail, you will find two tiny, hard, sharp claws poking right out of its body. And behind those little claws, buried inside inches of solid snake meat, sits a set of floating hip bones and a miniature femur. Evolution tried to delete the legs, but the python kept the receipts. Now, why on earth would an animal that specializes in slithering keep a pair of tiny butt claws? Why are those claws backed by actual hip bones? And how did scientists discover that every python egg on the planet is quietly trying to build a walking lizard before suddenly hitting the panic button? To understand how pythons cheated the system, we have to go back to the scene of the crime, 90 million years ago in the prehistoric dirt of Patagonia. For a long time, people assumed snakes lost their legs by going swimming and turning into eel-like sea monsters. But then paleontologists dug up a fossil named Najash rheonegrina. Najash was an ancient snake, but unlike any snake you will ever see in your garden, Najash had two fully formed, robust back legs sticking out of its side, complete with ankles, toes, and an actual sacrum. Translation: a sacrum is the heavy-duty bone bridge that locks your hips directly into your spine. Najash was not an eel. It was a snake that walked around on dry land with real, functional hips. So the starting point is settled. Snakes definitely used to have legs. Eventually, though, shedding those limbs became the ultimate evolutionary upgrade. If you want to burrow through tight underground tunnels, slither through dense grass, or swallow a deer 3 times wider than your own head, having 4 rigid sticks poking out of your torso is basically a liability. Most modern snakes understood the assignment. If you look at advanced snakes, like cobras, vipers, and rattlesnakes, they are absolute minimalists. They wipe their skeletal hard drive clean. They do not have leg bones, they do not have hip bones, and they do not have claw nubs. They took the legless lifestyle and ran with it, figuratively speaking, of course. Pythons and boas, on the other hand, are biological hoarders. Pythons belong to an older branch of the snake family tree, and they simply refuse to throw away the scrap parts. Those little claw-like spikes near their tail are officially called pelvic spurs. And they are not just funny-looking scales. If you take an X-ray of a python, you will see a shrunken pelvic girdle, the remnants of hip bones, along with a reduced femur bone connected straight to the claw. Scientists call these vestigial structures. Now, a lot of people think the word vestigial means completely useless, like that random HDMI cable in your junk drawer that does not plug into anything you own. But in biology, vestigial just means a body part that shrank down from what its ancestors used it for. It is the anatomical equivalent of keeping the box your television came in, just in case. And that brings us to the first massive question. If pythons do not walk, how do those tiny leg remnants get built in the first place? In 1999, researchers decided to peek inside developing python eggs to see what happens while the embryo is growing. What they found sounds like an evolutionary glitch. In the very early stages of development, a baby python embryo actually begins growing hind limb buds. Tiny little leg nubs literally sprout out of the embryo's sides. The construction crew shows up, pours the concrete, puts up the wooden scaffolding, and gets ready to build a 4-legged lizard. And then, out of nowhere, the entire project gets canceled mid-build. The limb buds stop growing, stall out, and slowly get reabsorbed by the body before a foot can ever take shape. The python does not lack the blueprints for legs. The python actively starts building them and then pulls the plug at the last second. To figure out who was pulling the plug, geneticists looked into the snake's DNA, and they ran straight into a gene that is legally, scientifically named Sonic Hedgehog. I am not making that up. Developmental biologists in the 90s named it after the blue video game mascot, and it happens to be the master controller for building arms, legs, and digits in almost every creature with a backbone, including you. When a python embryo is growing, its Sonic Hedgehog gene turns on right on schedule. The blueprints are completely intact. But a few days into development, the signal abruptly dies. It turns out the villain in this story is not the gene itself. It is a tiny strip of regulatory DNA called an enhancer, specifically one named the ZRS. Think of the Sonic Hedgehog gene like a high-powered light bulb, and think of the enhancer like the wall switch that controls it. In pythons, the light bulb is fine, but the wall switch is broken and full of mutations. It turns on for a split second, flickers, and cuts the power before the leg can finish forming. In 2016, scientists decided to test just how intact those snake blueprints really were. They took the broken limb switch from a snake and swapped it into mice using gene editing tools. The mice grew severely stunted, barely their limbs, proving that the snake switch was indeed degraded. But when researchers looked at the python's broader genetic toolkit, the takeaway was undeniable. The instructions to build a full leg are still sitting inside the python's DNA, archived in a folder that evolution forgot to delete, which leads to the biggest twist of all. If the leg switch is broken, and if dragging around useless bone fragments burns energy, why hasn't natural selection cleaned up the python's skeleton like it did for cobras and vipers? Why keep the pelvic spurs at all? Because the python found a brand new job for its broken legs. If you examine the spurs on a male python versus a female python, you will notice that the male spurs are significantly larger and thicker. They are sexually dimorphic, which is just the scientific way of saying the boys have bigger gear than the girls. Even wilder, those spurs are not dead, immovable chunks of bone. They are attached to living muscle tissue and nerves. A python can actively flex, pivot, and articulate its tiny butt claws whenever it wants to. And what does a male python use his articulated claw-tipped leg remnants for? Romance. When mating season rolls around, a male python does not have arms to hold his partner or legs to position himself. So instead, he crawls up alongside the female and uses his pelvic spurs to rhythmically stroke, scratch, and tickle her sides. Biologists have documented males alternating their spurs between horizontal and vertical angles, gently tapping the female to stimulate her and coax her into aligning her tail with his. In some boa and python species, males will even use these spurs as gripping hooks during wrestling matches to pin down rival suitors. Natural selection looked at a failed, abandoned set of back legs and went, you know what? That is not walking gear anymore. That is a romantic back scratcher. The legs did not survive because evolution was lazy. They survived because the moment they stopped being useful for transportation, they became an indispensable tool for courtship. The python took the ultimate evolutionary downgrade, losing all 4 limbs, and salvaged the spare parts into precision mating hardware. So the next time someone tells you that evolution is a neat, perfectly planned master blueprint, remember the python. It took an ancient, walking lizard, stripped away its feet over 90 million years, broke the molecular light switch in its DNA, forgot to empty the hip bones from its skeleton, left the embryo still trying to build legs every time an egg is laid, and turned the leftover claw nubs into an exotic dating technique. The python never truly let go of where it came from. The legs are gone, but the ghost of the lizard is alive, flexing 2 tiny claws in the dark, reminding everyone that nature never throws anything away if it can find a weirder way to use it.